Students, coming to the next topic in 8051 microcontroller is the memory organization. So in the previous video I explained about the different types of interrupts that are used in the 8051 microcontroller. Now let us see the memory organization of 8051 microcontroller. So how the memory is organized. So I already said this 8051 microcontroller is everything is inside, means the CPU, ROM, timers, serial ports, everything will be present inside the chip. So inside or outside, whatever it may be, if you want you can add the external RAM and the ROM. Other than this, you can connect the external chips also. So how the memory is organized internally and externally. Now let us see. The first 8051 microcontroller memory is divided into program memory and data memory. So 8051 memory is divided into two parts. First is the program memory and the data memory. Program memory is nothing but ROM, that is a read only memory. So which is used, it is used for permanent saving program being executed. So whatever the permanent program that is there, that is being executed with the help of ROM. So ROM is nothing but a program memory, and data memory is nothing but RAM. So a data memory is stored in RAM and the program code will be stored in the ROM. Okay. So RAM is used for temporary storing and keeping intermediate results variables. So that is about the data memory. So the first memory organization of 8051 is divided into two parts, program memory and the data memory. So this is ROM is nothing but a program memory and the RAM is the data memory. So 8051 executes programs stored in program memory only. Okay. And 8051 memory organization allows external program to be added. It also allows external program memory also to be added. External program memory means ROM. If you want, add external program memory as well as the data memory. Okay. Now let me explain about two types of data memories will be there. One is the internal and another is the external. So let me explain that. Internal data memory. So internal data memory contains all processor states. So that's internal data memory will be divided into lower, whatever that internal RAM is there, that will be divided into lower 128 bytes and upper 128 bytes. Lower and upper 128 bytes. So lower 128 bytes is used for general register and general data will be stored, whereas an upper 128 bytes is again divided into indirectly addressed and directly addressed. So upper 128 bytes we can store the direct address or indirect address. So indirect address is 128 bytes used for stack and this used for the special functions. So that is about the internal data memory. And coming to the external data memory. So the external data memory is external data memory. External data memory, first it resides on off chip. On chip means inside the 8051 microcontroller and off chip means externally connected. Okay, so this is 8051. Externally you are connecting one chip, so which stores the external data memory. external data memory. You call this as a off chip. And inside RAM, inside 8051 you are having the RAM. So this you call it as on chip. If it is present inside 8051, you call it as on chip, and outside the 8051 microcontroller, you call it as off chip. So this is resides off chip, and it accessed using the data pointer and MOVX register. So we can access this RAM by using the data pointer and MOVX register. You have to remember, while you are writing the assembly language program, if you want to access the external data into the 8051 microcontroller, then you have to use these two registers, data pointer registers and the MOVX registers. Okay. We will use the small memory model here, and all data is that is present, that is on chip, and it should be limited to only 128 bytes of data. So this is about the external data and internal data that is present in memory organization. So let me show you this memory organization. How does the microcontroller handle the external memory depends upon the pin external access logical state. Suppose how the microcontroller handle the external memory. Suppose this is an external ROM which is of size 64 kilo, maximum 64 kilo size. So whenever the external access pin is 0, it won't be embedded with the microcontroller. So whenever the external access pin is 1, then this chip will be embedded to the 805. This is 8051 microcontroller pin, a chip. Okay, so let's take this is a microcontroller 8051 chip. So in this chip already on chip is there, ROM. So this is the ROM. Internally the embedded ROM is there, that is of size 4K. So 4K means it starts, the address location starts from 0 to 3FF hexa value. So up to here the memory location, the 4K is stored from 0 to 3FFFX. Suppose I want to add external memory, external ROM memory, then you make the external access pin enable, then this ROM will be embedded here to this pins. So this will be embedded to this pins. So whenever it is embedded to this ROM, the address location will be start after this location. So this is 3FF. So now the starting address of this additional ROM is 4000. From 4000 to FFFF hexa value, means complete 64 kilobytes. Okay, so just how we are going to be embedded to the external, means how we are going to access the external memory, means like this. So whenever the external access pin is 1, then you just add the additional ROM to this 8051 microcontroller. Okay, so now after the, so this embedded RAM, the on-chip ROM will be from 0 to 3FFF, and from the external additional ROM will be starts from 4000 to FFFF hexa value. So this is the representation of memory organization. Inbuilt, you are having the on-chip ROMs, and if you want to add external memory, then you can add by making external access pin enable. Thank you.